The next thing on our slide is how
I
to
don't hear you.
plot graph. Now, when you are asked to plot a graph, it is expected that your graph should cover at least 2/3 of the graph page, unless on special cases. Now, for instance, the major thing you need to know in graphing is this: your scaling. Your scaling. You either use 1 centimeter or 2 centimeter to represent 1 unit, 2 units, 5 units, or 10 units. You don't use 1 centimeter or 2 centimeter to represent 3 units, 4 units. It is very wrong. For a standard physics graph, you either use 1 centimeter to represent 2 units, 1 unit, 2 units, 5 units, or 10 units. Or in fractional terms, that means in decimal, you can use 1 centimeter or 2 centimeter to represent 0.1 units, 0.2 units, 0.5 units. That's what it should be used. But it is never allowed. This here is never allowed in physics practical. These ones we're having here: 3 centimeter, 7 centimeter, 3 centimeter, 7 centimeter, or 9 centimeter. It is never allowed to use this scaling in a standard physics graph. Now, the next thing is this: we should locate a point on the graph page, 2 perpendicular lines called x and y axis, drawn intercepting at the origin. What does this mean? It is very simple. I should create a space here. This is what it means. Your y and x, they intercept. What I mean by intercepting, it means they meet at a point. So the y and x axis will meet at this point, known as the origin. That is O, point O. But not for all graphs. We should take note. Not for all graph fish. It is allowed that both the x and y axis should start at point O. We should take note of that. Sometimes the y-axis might start at some points other than O, depending on how spread our data is. For instance, if our data is much on the y-axis, we can say let our y-axis start at 2 centimeter, and our x-axis should start at 0. So we'll write on the scaling to be 0, 2. 0,2 to show that our x-axis is 0, but our y-axis is starting from point what? 2. Are we following?
Yes.
Okay, let's go to the next part. Now the next part says the next part says the y-axis of coordinate is called the vertical coordinate, like I told you, while the x-axis is called the horizontal coordinate. But basically, we should take note, in most of your physics graph, you'll be giving only positive value, or you'll be getting mostly positive value. So you will not be plotting what we call a quadratic graph. All your graphs will be linear. That means these are your graphs mostly will look like when you are plotting graph in physics. This is what we call a linear graph. We call it a straight line graph. It will either look like this or look like this. Can we see the screen?
Yes.
Now, this first one is known as positive graph. This number 1. Let's say this A. And this other graph B, we call it a negative linear graph. This one first is called a positive linear graph. And this B part is called a negative linear graph. You should take note of that. So mostly your graphs will look like this, either this or like this. Either this or like this. So let's go to the next part. This is how a standard graph in physics looks like. Now, when we're talking about graphing, I told you guys something. The first thing first, you must write the title of the graph. Yeah, we're having a graph of T against what? L. The value of T there is, the unit of T there is what? Seconds. While the unit of L here, which is known as the length, is what? Meter. It must be written there. Now, these are our axes.
Are we allowed to use, are we allowed to use biro to write on it?
No. When you are plotting your graph, you are not allowed to use biro. On your graph sheet, all data you are recording on your graph sheet should be made with pencil. Should be made with pencil, and your pencil should not be blunt. It should be sharp, so that your plot will be done in order. Are we with me? Are you all with me?
Yes.
Yes.
Okay, let's continue. Now, the next thing we are to do after labeling our axis, we said the y-axis is what? T against what? L for the x-axis. Now,
Oh God.
hope I'm not too
The
fast.
x-axis is the L, which is the length.
Hope I'm not too fast.
No.
Okay. The
Please,
x-axis
can
is your L,
Hello,
while your y-axis is your what? Your
hello, can you hear me?
Yeah.
Please, can you go back to the first slide? Sorry. The other one, the y-axis stuff, the one you talked about before entering this one.
okay. Okay. The y-axis or coordinate is called the vertical axis. So when you are, for instance, now let's take an instance. If I'm asked to plot t squared against L, are you with me? If I'm asked to plot t squared against L, my t will be on the y-axis, while my L will be on the x-axis. Are you with me? Hello?
What?
Yeah.
I can hear you.
Okay, let's go to the next slide. Our next slide shows a graph. We said a graph of t against L. Now, like I told us that we represent the point plotted on the graph with a dot. Now, the dot will not be as bold as this, so we should take note of this. It should not be as big as this on our illustration here. It should be as small as possible so that it can contain the point we are plotting. Is it clear?
Yes.
Okay. Let's go to the next one. Now, I said when plotting a graph, mark each point by a dot and a circle, and circle it alternately with a cross using a sharp pencil. So we're asked here to either use a dot or a cross, and your pencil must be sharp. Take note of that. Now, the next thing to take note of is this.
Please tell them to mute the mic.
Hello?
Hello.
Hi.
Please, let's mute our mic, please. Let's mute.
Okay, sir.
Let's mute our mic. When I want to ask question, I will tell them to mute it. Let's mute our mic.
The host can actually mute everyone to avoid this interruption. No, the host can actually mute everybody right now.
Okay, let's continue. Let's continue. Now, the slope of a graph is the rate of change of the quantity. Now, let's take for instance, we have the graph. Let's say we have a graph of this sort here. We have a straight line graph. Now, the straight line graph, for our slope, it will simply be a triangle. The triangle tells us the rate of change. The rate of change of a particular quantity. The rate of change of a particular quantity. Let's say we are plotting y against x. Y against x. To calculate our slope, we say slope is change in y. Change in y divided by our change in x. And in physics, we say change in such value simply means y2 minus y1, y2 minus y1 divided by x2 minus x1. That's how we calculate our slope. Another thing we should take note is our intercept. The intercept we are basically finding in physics practical is the y-intercept. Let's take note of that. The y-intercept. The y-intercept is the point where the straight line cuts across the y-axis. Let's say this is our graph. This point where it cuts across the y-axis on our graph is called the y-intercept. It can be 2 centimeters, 2 seconds, depending on what we are plotting against each other. For instance, if I'm plotting T against L, the y-intercept will simply be 2 seconds if the line cuts across number 2. Now, the next thing we should take note, let's go to the next part. Now, we should take note of a very important thing. When plotting your graph on your graph sheet, you are not allowed to make any calculation on the graph sheet. It is not permitted to make any calculation on the graph sheet. You are not permitted to make any calculation on your graph sheet. The calculation should be done on the next page after plotting your graph. Now, let's go to the next slide. We want to look at types of graph. We have several types of graph. We have a straight line graph, which you will come across mostly in physics practical. We can call it a linear graph, or can call it a straight line graph. So yeah, we have a linear graph or a straight line graph is obtained when the quantity on the vertical axis increases with the variable on the x-axis. So let me show us how a linear graph looks like. A linear graph looks like this. This is your linear graph, also known as a straight line graph. This is your linear graph here. So going to the next part of our slide. Our next slide. Okay, this is a linear graph here. This is an example of a linear graph. This is a straight line graph, or we'll call it a linear graph. The y-axis increases with an increasing x-axis. As the vertical axis increases, the x-axis also was increase. Now the next type, we look at the slope. Like I told us, to calculate slope, since I'm plotting, in this case here, we're plotting y against x. Since I'm plotting y against x, my slope will now be change in y divided by change in x. So in an instant, I'm plotting t against L. My slope will be change in t divided by change in L. So that I'll be having what? Yeah, since it's change in y divided by change in x, here will be y2 minus y1 divided by x2 minus x1. So a graph that the slope upwards has a positive slope. What does this mean? This is what it means here. Let us show a graph here. Let's say we have the graph. If the line goes like this is known as a positive slope. But if the line comes like this, here is known as a negative slope. So if the line is going upward this way, we have a positive slope. And if it's coming downward this way, we have a negative slope. So let's go to the next slide.
Please excuse me.
Okay.
How do we know y2 and y1?
Okay.
Like x.
That is a very good question. That's a very good question. Now, let's say this is our graph here. Okay, let us go to the previous slide we have here. Let's go to the previous slide. Let's go to the previous slide. Now, yeah, for you to know your y2 is always the highest value on your y-axis, yeah, while your y1 is always the least value on your y-axis. Yeah, if you see this graph here, yeah, I'm having y2 and yeah, I'm having what? Y1. Why for your x2 and x1? Where your y1 begins, that's where your x2 will begin. So yeah, we are taking x2 downward and x1 downward for this type of graph here. Are you with me?
Okay.
It's clear now, Ba?
It's clear, yes. That is the highest value is the y2.
Why the least value is your y1 on your y-axis? Why the x2, the least value on the highest value on your x-axis here is your x2. Why the least value there is your x1? Now, let us take another graph. Let's say we're having this type of graph. Let's say we're having this type of graph. Our y2 will be the highest value as usual, and your y1 will also be the highest value, the least value as usual on the y-axis. But your x2 here, we start from where your y1 ends. That means your x2 here will be your least value. Since this type of graph is a negative graph, this type of graph here, we're having a negative graph. So your x2 will start here, and your x1 will be the highest value. So for an instance, if I'm having this type of graph, your x2, let's go forward, sorry. Okay. Yeah, your x2 will be the highest value for this type of graph, while your x1 will be the least value. But for this type of graph here, we're having your x2 will be the least value, while your x1 will be the highest value. So this is how we calculate our slope, y2 minus y1 divided by x2 minus x1. So yeah, we have a straight line graph can slope downwards as shown in the figure 2.2 below. This type of graph is obtained when the quantity in one of the axes increases with a decrease in the quantity in the other axis. This is what it means here. This is a type of a negative linear graph. This type of graph is a negative linear graph. Your y2 is the highest value. Here it's supposed to be y2. Why the least value here is what? y1. To take note of that. Why your x2 will begin here, where your y1 ends, is a typographical error. Your x2 will begin here, your x1 will end here. So that at the end of the day, when you calculate your slope, you will be having a negative answer. You'll be having a negative answer. So here we're having the same formula for slope, change in y divided by change in x. So we have y2 minus y1 divided by x2 minus x1. I guess we are following.
Yes.
Okay.
It's clear.
So let's go to the next slide. Now we have another type of graph. Another type of graph, non-linear or curved graph. This type of graph, you might not come across this type of graph when doing experiments. But these are the graphs we usually look like. We have curved graphs like this. And for us to find the slope, you just draw a triangle across the path that it curves the most. This type of slope, we call it the tangent to the curve. It's called the tangent to the curve. But in your first year physics practical, you will not come across this type of graph. You might not come across this type of graph. Virtually all your graph will be positive graph or negative straight line graph. So we have other types of slope. This is another type of curve graph there. Now, this is another very important concept. And this important concept, I want every one of us to follow vividly. Here is known as the linearization of graph. In simple terms, without bugging our heads, linearization of graph simply means turning a curved graph into a straight line graph. Turning a curved graph into a straight line graph. And straight line graph covers this equation here. Our equation of a straight line, y equals to mx plus c. So if you are given a particular type of graph, you are simply asked to turn the graph to look like something like this. Y equals to mx plus c. Where this our m, we call the m the slope. Your c is called the y-intercept. Your y is called the variable on the y-axis, and your x is called the variable on the x-axis. So this y is called the dependent variable. Your x here, we call it the independent variable. Your y here is called the dependent variable. So it's depending on the value of x. So whatever value of x I have here, it will give me the value of y. So we should take note of that. When you are asked to linearize a graph, you are asked to simply make the graph look like this. Y equals to mx plus c. So if c equals to 0, your graph will look like this here. Y equals to mx. But if you have the value of c, your graph will look like this. Y equals to mx plus c. That is for a straight line graph. So in virtually all your graphs, you'll be asked to turn your variables to look like a straight line graph. That simply means linearization of graph, converting the graph to look like a straight line graph. Let's go to the next slide. Now let's look at this equation here. Now the equation of a straight line enables us to transform equation into quadratic or exponential forms in such a way they take the forms of equation of straight line. Now let's consider this equation. Let every one of us put on our mic, please. Let's put on our mic. Now if you consider this equation, t equals to 2 pi square root of h minus l divided by g. Does that equation look like y equals to mx plus c? Can you identify your m there? Can you identify your x there? Can you identify your c there? Does it look like y equals to mx plus c?
No.
It does not look like it, but now,
No.
these types of equation here, will be asked to convert this type of equation to look like y equals to mx plus c. How do we do that? That's when the theory of linearization of graph comes into place. Now, the first thing you should take note, the first thing you'll be asked to take note is to know what you are plotting against the other. For instance, they say where h here and g are physical quantities to be determined. Here simply means we are going to determine the value of g. We are going to determine the value of what? H. So it simply means that you are plotting the graph of t against L. That's what the graph will be like. So they said if a graph of t is plotted against Earth, a parabolic graph is obtained, and the value of g and h cannot be obtained from the curve. That means if I'm to plot this graph like this, it will give me a parabola. So that is why it is important to turn the graph to look like y equals to mx plus c. So for this instance, you'll be told on what you'll be told on what to do. Now for this type of graph, you'll be asked to plot a graph of t squared against L. So if I'm asked to plot a graph of t squared against L, before I will plot the graph of t squared against L, I will need to turn it to y equals to mx plus c. Are we following?
Yes.
Okay, let's move forward. Let's go to the next slide. Okay, let's go to the next slide. And this is a very good thing here. Now for the next slide here, they say the equation can be transformed into a straight line graph by squaring both sides. Now this is our first equation first. This is the equation for t equals to 2 pi. We have 2 pi square root of h. We have h minus L divided by G. This is our first equation we're given. Now, you have to square both sides. That means you will square the left-hand side and the right-hand side. Why are you doing that? You have to remove, the reason why we are doing that is to remove this square root sign we're having here. This square root sign we're having here. You have to square both sides. You remove the square root sign. So here we're having t squared. You have t squared equals to 2 pi. We have 2 pi. So 2 pi. We'll square 2 pi 2. Now, if I square the square root sign will go out, true or false? Square root and square, when they meet, it will cancel out, Abi?
Yes.
So here we have our h. We have our h minus L divided by G. Divided by G. Now, if I square 2 pi, 2 square will give me 4. And pi square will give me a pi squared. True or false? Now, when we open up the brackets, you have 4 pi times h here. Here we have t squared. T squared equals to 4 pi. When we square the first bracket, we have 4 pi. 4 pi squared into h minus L divided by G. Minus L divided by G. So when you open up the bracket, you have something like this. Now, the first thing I told us something that we are plotting t squared. You are plotting t squared against L. The reason being that we are asked to find the value of h. They told us that we're finding the value of h and we're finding the value of what? G. Now, the first thing is we are not going to compare this equation we're having here. After squaring and opening up the bracket, we are comparing this equation with your equation of straight line. Y equals to mx plus c. So our y here will be what? T squared. Your x will be what? L. Your c will be everything you're having here. Your c will be everything we're having here. This place I cycled will be your value of c. Now, the next thing we'll be having here is our slope. Our slope will be minus 4 pi squared divided by g. First thing first, your y is t squared, your x is L, your c is the next value you're having here. That's our equation of straight line. We're comparing it with our equation of straight line. While your m, which is your slope, will be the value, remaining value standing beside your value of x. That is our L. That is minus 4 pi squared divided by g. Are you? Are we following?
No.
Yes. sir.
You understand how we converted it into t squared equals to minus 4 pi squared L divided by G plus 4 pi squared H divided by G. True or false?
True.
Okay. Now the next thing is to find your y, the value that is supposed to be on your y-axis, the value that is supposed to be on your x-axis. Now the first thing first, you should know what you are plotting against each other. Now in this type of graph, we are plotting t squared against L. So your y will be t squared, your x will be what? L. Now, we recall that our equation of straight line is y equals to mx plus c. True or false? Now, we've identified our y, we've identified our x. Hello? Hello?
Hi.
Okay. We've identified our y,
I can
we've
hear you.
identified our x. Now, the next thing is to identify our m and to identify our c. Now, our m will be the value standing beside L. All the values standing beside L will be your m, that is your slope. While the next value there will be your c, that is your y-intercept. So we can say that c, your intercept c equals to 4 pi squared h over g, while your slope will be this next value here, minus 4 pi squared divided by g. Now with this, we've said that we can say that we've linearized this graph. We've turned this graph to look like y equals to mx plus what? C. Is it clear? Is it clear?
Yes, sir.
Okay, let's go to the next slide. Let me clean this. Let's clean this. Now, the next thing is how to calculate our error in slope. How to calculate our error in slope. Now, your error in slope, this is how it is calculated. We have our formula for error in slope. Now, if you are given the graph, there are two ways we can calculate our error in slope. Your error in slope is virtually calculated from your graph, and this is the formula we use in calculating our error in slope. Error in slope, S subscript X equals to 4W divided by NR. Your W is known as the vertical scatter. Take note of that. W, yeah, is known as the vertical scatter. N is known as the number of points that you plotted on your graph. So if you plot 6 points, if you plot 8 points, that will be your N. While your R is simply the range on your X axis. We know our range. Our range is simply the difference between the highest value and the lowest value on the X axis. Is it clear? Is it clear?
No, sir.
Now, in your graph, I will show us an example of a graph.
Exactly. No, we
This is
don't
an example
understand
of
you.
your graph. The standard error in slope or error in slope. This is the formula 4W divided by NR. That's the formula we use in calculating our standard error in slope. Your W means vertical scatter. Your N means the number of points, while the arrow means the horizontal range. Your arrow means the horizontal range. That is the difference between the largest and the smallest value on the X axis. Is it clear now?
It's clear.
Now, the
Yes, sir.
next thing is our standard error in intercept. This is the formula. The standard error in intercept. So we have square root of W over N all squared plus X bar divided by standard error in slope all squared. Your W is maintain the same value, the vertical scatter. Your N is your number of points. Your X bar, take note, This X here is bar. Your X bar is simply the mean on the x-axis. So you are going to calculate the mean on the x-axis. While your S subscript S here is your standard error in slope. Your standard error in slope. That means, it simply means that you will get the standard error in slope first before you can get your standard error in the y-intercept. So your X bar means your mean, your XX means your standard error in slope. Then you take the square root of your value there. So we should take note of this formula. This formula, we're using it to calculate our standard error in the intercept. Are we with me? Are you all with me?
No, please just explain that
No.
this last formula. I didn't
Now
understand it well.
this next one here means your standard error in intercept. This is the formula: square root of W divided by N all squared plus X bar S subscript S all squared. So this raised to power half means square root. That's why I say square root first. So your W here means your vertical scatter. Let's take note of that. Your N here means the number of points you plotted on the graph. Your X bar here means your mean on the x-axis. Why this your S subscript S here means your standard error in the slope. Then you take these values and you find the square root of it. That's how you calculate your standard error in the intercept. Are we following?
But what is W scatter?
So I'll show us an instant. There's a graph that will show us an instant to show us the vertical scatter. Is it clear?
Vertical scatter.
Yes, vertical
Okay.
scatter. We call it the vertical
Yes, sir.
scatter. So let's go to the next slide. Okay. Now this is our graph here. Now,
Yes.
before we move forward, this is a graph of t squared h against h squared. T squared h against h squared. You can see how it is labeled on the graph sheet here. Now, we say W is our vertical scatter. Now, in secondary school, you were told that your graph should contain at least 3 points. 3 points should enter. Abi?
Yes.
That's what we were told in secondary school. But yeah, you'll be learning that your line of best fit is not necessarily 3 points. Your line of best fit should be